Okay, class, we're back to, and now I'm in GI2, Gastrointestinal 2, in my PowerPoint series in my website. Okay, let's see where we're going with this. The pharynx, oropharynx, laryngopharynx. Now this, we saw this picture before. We have a nasopharynx, an oropharynx, and a laryngopharynx. Okay, that's the epiglottis. So we're interested now in the oropharynx and the laryngopharynx, and really more the oropharynx, because remember the fork in the road comes at the laryngopharynx area where food and air separate. Allow passage of food, fluids, and air. Okay, that's going to be the oropharynx and the laryngeal. Stratified squamous epithelium, skeletal muscle layers, inner longitudinal, outer pharyngeal constrictors. See, we have an upper esophageal sphincter and a lower. But anyway, let's keep going. Okay, esophagus. So now we are to see, here's that esophagus. Remember what I told you in respiratory? That if I put a nasogastric tube in and just stuck it in the nose, or an orogastric, if I just stuck it in the nose or in the mouth, 99% of the time it's going to go because of how the angle of gravity. Remember I said to get something in the trachea is harder because the trachea is further forward. That's where we got into that intubation issue. So here I'm interested not in respiratory, but obviously in gastrointestinal. So we're going to come back and we want to go down here, not into here, right here. Okay. So the esophagus, which is this tube here, is a flat muscular tube from the laryngopharynx to the stomach. Pierces the diaphragm. Okay, it goes through the diaphragm. See the diaphragm, here's that diaphragm right there. And here's that esophageal hiatus. That's the hole in the diaphragm that the esophagus goes through. Here's the diaphragm again, and here's that hiatus. We'll come back to that again. All right. So what do we have here? It's a flat muscular tube from larynx to stomach, pierces diaphragm at esophageal hiatus, joins stomach at the cardia region. And we'll see, we're going to get to the stomach in a little while. All right. Let's go further. Esophageal mucosa contains a stratified squamous epithelium, changes to simple columnar at the stomach. Remember, stratified squamous is more to handle abrasion. Columnar is more an absorption. Esophageal glands in the submucosa secrete mucus. See the mucus and they really secrete mucin. The book wrote this. They secrete mucin, and the water on top becomes mucus. Okay, skeletal. So the way this goes, this is kind of how we see it in the medical thing. If I look at the esophagus, the upper 1/3 of the esophagus really is skeletal muscle. That means technically you have voluntary control. That's how those sword swallowers. Now they're y'all young, but in the old days at the circus, they used to have sword swallowers. So the upper 1/3 is mainly skeletal muscle. The middle 1/3 is a mixture of smooth and skeletal, and the last 1/3 is totally smooth. So you really so really that middle 1/3 you really don't have any control of, but that upper 1/3 you do. Now most people don't develop that, but you could. Okay. Adventitia instead of serosa, because this needs to lock into position. Remember, the serosa is going to be in the intestine area. We just did that a little while ago because you want them to move freely away from one another. But this here has a adventitia. Adventitia is a connective tissue that seals you to the surrounding structure so you don't move around. Okay. Here's that picture again. And so here's that stratified squamous epithelium right there. And see right here, you're showing a stratified squamous moving into a columnar kind of thing. Stratified squamous. Okay. Go further. Digestive processes in the mouth. So here's the mouth. Ingestion. mechanical digestion. What does that mean? That means the chewing up. And that chewing up is going to take you into a bolus of food, the teeth assisted by the tongue. The mastication is partially voluntary, partially reflexive, because once you get back here a while, reflexes, what we call that deglutition swallowing, is going to take over. But the initial part, you got to chew. You have mechanical digestion, that's breaking the food up. And then you have the chemical digestion, which is to add enzymes. Salivary amylase, we'll be coming to that in a later video. But salivary amylase is for carbs, help break up carbs, and lingual lipase. Now the whole thing, in case you don't know, let me just refresh you on this in case those that don't know. Absorption occurs, so here's kind of an overview real quick to kind of give just the quick. Absorption occurs mainly in the small intestine. Absorption occurs in the small intestine. Okay. Absorption means, if I'm talking about on the molecular level, that the food needs to be in the monomer form. Now let's review. The food needs to be in what? The monomer form. Okay, you say, what's a monomer? Okay, if we're talking about carbohydrates, a monomer is a monosaccharide. If we're talking about lipids, we're talking about fatty acids. If we're talking about proteins, we're talking about amino acids. That's the monomer. Now, you don't eat it in the monomer. You eat it as a whole chunk of food. So it's polymer and everything. So it's a whole chunk of food. So you have to first of all get the mechanical to break it down where the enzymes, break it down into pieces where the enzymes can get to it. They can wet it up, get to it. Okay? Now that's on the more mechanical. On the chemical level, those enzymes have got to break those polymers to monomers. And that needs to be done prior to and within the small intestine. Here I said prior to and within. So you first started your mechanical and chemical breakdown in the mouth to get things started. From the mouth, you chew it up into pieces called boluses. And then those boluses, which are smaller chunks, can be wet by saliva, and within the saliva would be the enzymes starting. Well, the two enzymes are going to be amylase and lipase. So you can start working on fats and carbs in the mouth. You don't work on proteins at all. They need too strong of enzymes. So the first time you're going to work on proteins is going to be in the stomach. Now, the stomach does hardly any absorption. It absorbs, it's only three things the stomach kind of absorbs. A little bit of water. It also absorbs your drinking alcohol. That's why it hits the bloodstream so quick. And aspirin to a certain extent. And aspirin. But the stomach is not an absorptive area except for what I just named, and not a lot of that. So really the small intestine is that. And then anything that leaves the small intestine and goes into the large intestine is waste. So in the large intestine, you move a lot of water in there, and you need to reabsorb that water. You needed to move the water so it could go through the large intestine, but you cannot afford to lose all that water. When you lose too much water, that's diarrhea, but you're also losing a lot of electrolytes, particularly potassium. So if you listen to what I'm saying, that kind of gives you kind of an overview what to look for. You need to break the food up, wet it, enzymatically break it down so it's in the monomer, and anything that gets past the small intestine is waste. And what you need to reabsorb in the large intestine is leave the waste so you can defecate it, but remove some of the water and the electrolytes. So that's kind of a quick overview to kind of get you going. So in the mouth, you did mechanical digestion, chemical digestion, then you propelled it down. Deglutition is a fancy name again for swallowing. Okay. So deglutition involves the tongue. Let's go here. Deglutition involves the tongue, soft pharynx muscles, buccal surface, so forth. Now let's just run through this. You can read it. Basically, here's the key to this thing. What you need to do is that, we'll go back to this picture. You have an upper esophageal sphincter. Okay. So the first thing, let's just think about this. We're dealing, now this is a reflex, okay, where you got a deglutition center, AP1. A center is a nuclei in the brain. What's a nuclei? A cluster of neuron cell bodies dedicated to a function. You should already know that. We've done the breathing center, we've done all these centers. Neuroanatomy, nucleus. Neurophysiology, what it does, like the breathing center, the cardiovascular center. So you have a deglutition center in the brain that is like a computer program that does step by step these actions. Okay, what do I need to do? First of all, if I'm swallowing down, I don't want this opening because it'll go up through the nose. So I want to shift the palate back. When the palate gets shifted back by this center, then that closes the oropharynx from the nasopharynx, so food doesn't come in. So now food's going down. Now, what do I want to do next? I don't want food to go into here. So the epiglottis needs to close over the glottis. What? The epiglottis needs to close over the glottis, and I need to shift the trachea further forward. So muscles do that. Muscles do that. They're going to take the epiglottis, close it over the glottis, and shift this more forward. Now, then I have an upper esophageal sphincter. What I need to do with that is relax the upper esophageal sphincter. So where are we now? Close oropharynx from nasopharynx. Close off the windpipe. Open up the upper esophageal sphincter so things can slide down. Okay? Then as things slide down, peristalsis will take over to keep propelling this down. Propelling. So then what's going to happen primarily is going to propel. And then when I get down here, I need to open the lower esophageal sphincter, also called the gastro for stomach esophageal. So the LES, lower esophageal sphincter, is also called the gastroesophageal sphincter. So that's what these pictures are showing, which you have in your PowerPoint. You can read those yourself. There's no point in going point by point because I've given you essentially in a nutshell what's happening. And you can read to see. But the key is to get this bolus going down. Mucus is also helping it do it. The tongue has propelled it back. The tongue has propelled it back, and we've done all this stuff we said. All right? So what I'm going to do is, because again, you can read it too. I'm going to go past all of this here. Going past all of that. That shows this. And now let's get to, but before we go to the stomach, we've been talking about the esophagus. I want to just mention a few things. All right, here's some difficulties with the esophagus. One is achalasia. Achalasia is difficulty swallowing. A lot of times that has to do with something wrong with the esophagus, the muscle, too weak of muscle or whatever. The other thing we can get in this, it is a hernia. Now, hernia is an abnormal protrusion in an abnormal area. Right here, this lower esophageal sphincter is right here at the esophageal hiatus. So the esophageal hiatus helps with the maintenance of the lower esophageal sphincter. If for some reason the esophagus breaks free of this area and slides up and down, then that's what's called a sliding hiatal hernia. And that can cause GERD, gastrointestinal reflux. You can also have this paraesophageal hernia where a hump of the stomach gets in there. Just showing you some stuff. Okay. This here is a diverticulum. A diverticulum is an I made an error there. How did I do that? A diverticulum is an outpocketing of areas of the gastrointestinal system. Right here would be an outpocketing. My grandmother had that. She had to push in on that because the food wouldn't go down properly. Okay. Right here is gastrointestinal reflux disease. See this, when you get the food in the stomach, this should close so that you can work on the stomach. You got a whole lot of acid in there. If you have a weak lower esophageal sphincter, you can reflux back up. And when you reflux back up, you could do a lot of damage and even tear that mucosa there, Mallory-Weiss tear. I'm going to have to close here.